workshop. So it's actually going to be me and Siddharth doing the meeting today. We're going to do our meeting on 555 timers. 555 timer is just a very common component used in a lot of electronics. The basic of it is that it's a timer. You have an on voltage and an off voltage, and we rotate between the two. It can be used for a lot of other kind of purposes, and we'll show 3 of these kind of states today. We have some of these example circuits up here. So our workshop is going to be implementing at least one of these configurations. So yeah, let's, oh, there we go. Again, contact info. Ready to do announcements. Okay, so this is our content overview. We're going to go into what a 5.5 timer is, what does it do, how does it work, and then we're going to do our workshop with the what can I do with it. So again, our club is going around hobby electronics. So we're very interested in figuring out how we can use 5.5 timers to do things for us, make fun circuits and devices. So that's kind of our focus here. Again, I highly recommend you go to the electronics club at osu.edu to follow along with the slides. It's very, very useful later on when we do the workshop, so that you can actually see the circuit diagrams and everything. We often can't get everything all up here at once. Okay, so I'm going to hand it off to Siddharth here, who's going to.
All right, so first we're going to go over what is a 555 timer. So it is an extremely common precision timer IC. So you'll see a 555 timer in pretty much any application or any device that uses like a clock signal. Depending on the mode, it can be used as either a timer or an oscillator. You can also call it a flip-flop. It's extremely easy to use and inexpensive, as you can see. It's about 46 cents. And that's the internals of the 555 timer. It's got 2 comparators to compare voltage differences between different gates. It's got an NPN transistor. It's got a flip-flop, and it's got 3 5 kilo ohm resistors, hence the name 555 timer. Now, the resistors can be used to get like different voltage values from different gates. All right, so that's the first mode of the 5 timer. It's called monostable mode, also called a timer mode. So it can wait a certain time and then pulses high. So you can use it for like an LED flasher. Time, like the delay between each subsequent flash is determined by this formula. It's 1.1 times the capacitor value times the resistor value. Now, do you want to do the circuit first, Connor?
Yeah, sure.
All right.
So I can actually show here what our circuit is doing. We could probably run through all of the modes before jumping into our workshop. Cool. The one better there we go. There we go. So you can see very nice red LED up here. This is the one circuit that we'll be making today. So you can see that it's kind of pulsing on and off around like 1 second. So if you have a component that needs a clock signal, you can put this in the clock. You can also just make this fun flashy LED, feed a bunch of them together. We'll be doing this later.
All right, so what you saw was the astable mode. I'm sorry, we don't have the monostable. So I'll just go over the table. So this is called the oscillator mode. It pulses high and low in regular intervals, as you can see there. And the time delay is affected by the capacitor and the resistor connections. You can see the frequency of the output waveform over there. It's F equals 1 over T high plus T low, the time it takes. All right, we'll do that later. That's the circuit you're going to be doing today. Now we're doing bistable mode. I'll just show bistable mode real quick. In simple terms, it's basically a flip-flop. So if you don't have like a flip-flop ready with you, you can use a 555 timer to make a makeshift flip-flop. So I'm sorry. Do you have a different magic book?
Should be more. For those of you who don't know what a flip-flop is, an SR flip-flop, you can feed a signal into the set, which is the S, and it'll hold that value until you send in an R. So this is used in memory for all like computers or 3060, which on visual lighting, you've seen them a bunch. They're useful in a lot of different contexts. This is basically a very, very common IC that just so happens to also be able to be used as an SR flip-flop, which is used in a lot of different circuits as well.
All right, so if you can see this LED here, there's two buttons here, and one of them's the set button, the other one is the reset. So if I press the set button, the LED lights up. Now, if I press the set again, it doesn't light up, nor does it get low in a specific time interval, which means we're using it as a flip-flop and not using the clock functionality of the 555 timer. So in order to switch it off, we need to press the reset button, which resets the clock signal, and it switches off. Now that's the bistable mode. And Schmidt trigger. Connor, you want to do Schmidt trigger?
Yeah, it looks like, can you exit out of the, yes. Looks like our slide didn't update. We go. So a Schmidt trigger is a kind of specially like special device configuration. You can also implement them with a operational amplifier. They're used a lot in circuitry. One of their biggest uses is button debouncing. So when we press a button, it's never just like a on-off flip. Because we're working with a mechanical device, we have like a lot of button kind of noise going on. So that's really, really bad for certain circuits where, say, we have an LED flashing on and off. If we press that, it would be like flashing on, off, on, off, on, off, and then continue forward. So if we have like a signal that's like counting the number of button presses we have, this would count like 20 button presses from just one. So a Schmidt trigger can be used to get rid of this. So we just press it once, and then the voltage is just set high once, and we don't have to worry about button debouncing. So 555 timer used everywhere and can be used for this very common application as well. Another thing that it can be used for is converting sine waves into square waves. So the way that it actually works is that we can set a certain threshold voltage. So when our kind of input gets to a certain height or a certain voltage, it turns on. When it gets to a certain threshold voltage that's too low, it turns off. We actually have an example of here that I will find a better for. So for this circuit, we have a battery of 9 volts, and I set the threshold to be 1/2 of that, so 4.5 volts, and we're really jumping here. Absolutely right up this lean beat curve. There we go. So this little kind of dial here is called a potentiometer. So when I turn it one way, the voltage goes up. When I turn it the other way, the voltage goes down. Hello. So when we have a Schmidt trigger, we get to a certain high voltage, and it turns to green. Then we keep going high, it stays green. Now we're going to go back to low voltage. And when we hit the certain low threshold, we're going to turn back to red. So we keep going low, it stays red, back to high, then green, so we can go back and forth. So if you have a analog signal that's turning on and off, we can use this to say, hey, this is when we hit the certain threshold voltage, this is when it goes down. So if we input a sine wave into this, it'll come out as a square wave. If you haven't seen those before, this is what they look like. So just a kind of sine wave up and down turns into square wave based on certain set threshold voltages. Here's our circuit diagram for bistable mode, and we'll kind of jump into these other states as well. So these are up here. You can create these as well if you want to, but we're going to be focusing on monostable. Oh, sorry, on astable. We're going to be making an oscillator. Okay. So does anyone have any questions before we jump into the workshop?
Where do we get this?
Oh boy. I can send you an Amazon link afterwards. That might be a good extra for Discord. Looks like we have some chat up here. Oh yeah. I actually don't know what a tremolo effect is. Oh, volume?
Essentially, it's like quick fluctuations in volume.
Yeah.
It kind of, yeah.
Huh.
Oh,
Okay. Cool. Yeah. All right. So we're going to jump into our kind of workshop here.
Ian said he can provide an example later if you want.
Yeah. Oh boy. I think. So our circuit here is exactly like this, sans the transistor. So we're just going to have the output here go directly to a LED. So we're going to need, oh boy, one of each capacitor, one of the 33 resistor, or 330, and then 2 of the 10K. Ask me if you have any questions. You also need one LED, one 5x5. Of course, a breadboard and a 9-volt battery, and a lot of wires that we do not currently have. I'll go grab this real quick. But come on up, let's say first row, kind of grab this up.